And then we have 0 minus 1, but that's squared. We'll work that out in a second. Plus b times, now this is 0 plus 1, and then 0 minus 1, and then plus c, which we did find out to be 2, and then 0 plus 1. See? So we should be able to get b now. 0 equals, all right, this right here is, all of that together is negative 1. All right, how many b's we got here? This should be 1, this should be negative 1, multiply together, and then multiply times b.
Yeah, it's
So minus b.
yeah, minus b.
And then over here, this should just be plus 2. I think we're going to get b as 1. B is 1. We got them all. So we actually didn't even need the long way here, and we got lucky because we had 2 of the 3 from the short way. Now, I don't think it's a bad thing to expand this all out and then go and, it's a good exercise to get your algebra again, but, you want to be efficient. Yes, James?
If I took, let's say I just didn't know, I just let x be 0.
Mm-hmm.
Like, just kind of didn't know that. Could I just go ahead, like, since I got those two, since I got b and c already,
Yeah.
go ahead and take the equation, plug those back in,
For B and C. For A and C, yeah.
Right.
Mm-hmm.
and then just kind of like go from there and try to think, okay, well,
Like get the left and right to match up like we did?
Right.
Yeah, you could do that. Yep, yep. You would wind up basically having kind of like a system of equations, but
Right.
yes, you could do that.
okay.
Yep. All right, I think we're there, yes? Okay, so let's unpause. Let's unpause now. We were at 1/2 x squared minus x. Is that where we were, or was it plus x? It was plus x. And then we had plus the integral, right? But now that new integral right here, we hadn't even factored it yet, right? But we know that that new integral turns into this, right? And we know what a, b, and c are. So that new integral for us is, let's see, a, which is, what is it?
Negative 1 was that?
Negative 1? Yeah, I don't know, I forgot. But negative 1?
Yeah.
Negative 1 over x plus 1. And then we have plus b, which is 1 over x minus 1. And then plus c, which is 2 over x minus 1 squared dx. There it is. That's where we are now. And we are very happy to see all of those expressions, right? Because we enjoy integrating those. All right. What? Did I erase too fast?
No, it's okay. You're going to do the step right now.
I am?
Yeah.
I'm not, actually. Let's see here. Where's Alex? All right, Alex. This going okay for you, Alex? Yes. All right. You want to crank these out for me? Go ahead. Okay, everyone good with that? Constant over linear expression x, that's a natural log. Didn't have to account for any scaling because there's a 1 here, but you did account for the negative. Keep going. Plus. Good. Everyone good with that? Okay. Oh, careful. See, because it's squared, right? So this was, we talked about this last class. If you have constant over linear, we're natural log all day long. But if you have constant over linear repeated, this is going to be like a little u sub. This thing looks a lot like this, Alex. This should look in your mind a lot like this, which is really this. So I'll give you a moment to kind of think about that. You fire away when you're ready. 2, positive or negative? Positive. Negative. 2 over x minus 1. That is right. Plus c. Okay. So I don't want to go through too much of this to here because that is something we did last class, but I understand people are maybe not here yet. but please make sure, yes?
Isn't that going to be negative 2?
You're adding 1,
Oh,
right? So negative 2 plus, yes?
yeah.
Okay. That is the correct answer. You get full credit on a test for that. So you would get full credit if you got that answer on the test. But if you put that answer, I would just I'd just smile. I'd just be like, oh, that's good. That's good. So what is that? What did that student just do?
Oh, they do log property.
Just use a quick little log property. It's not more right? This isn't more correct than that is. They're both correct. But this shows the student recognizes 2 logs, subtraction between them if you change the order, and then subtraction becomes division. So like if you go look in the back of the book for the answer, they're probably going to have this. You're like, what? And then you realize that's what happened.
Wait, so
Yes.
are you saying that X and Y would be plus, or
What's that?
would be
Oh,
plus?
did I not put, I didn't put a plus, so yes. Sorry, that would have been wrong. My fault. Plus, I did forget the plus. Okay, yes? It's 205. All we've done so far is what happens when we have a linear on the bottom, right? A over that. If it's repeated, you might need like B or C or D. Let's see what the next example has in store for us. Adam, you've already participated. James, you've already participated too. So I'm just trying to get around to everyone. How about Elijah? All right, Elijah. So what's your first thought here? Like very first thought. What was when I put that up there, what's the very first thing that came to mind? No long division? Is that what you're thinking? Good. Yeah, there's no long division here because the power on the top, right? But let me suggest something, Elijah. The first thought should have been, is there anything easy? Okay? Look, because when you get to the test, trust me, you do not want to try and be doing partial fraction decomposition on a problem that would have been something easier, right? Like, can you imagine wasting 30 minutes and then realizing it was like that? And it wouldn't be me trying to torture you. It's just like, that's part of what I'm testing is, are you going to commit to a process and then realize later, oh crap, This is what we were talking about the other day. It's like you have to practice until you get comfortable. All right, but you're on the right track because fortunately this is what we're talking about, partial fraction decomposition. So no long division. Then Elijah, what will we do then if there's no long division? Well, if we're going to do partial fractions, the first thing we want to do is write down the integrand and do what to the denominator? What have we been doing? Factoring, right? So that's always what we're going to do. Once we commit to partial fractions, we get past the long division step if we have it. Here we didn't. So then you write the expression down and you try and factor out the bottom. And all we have on the bottom is a GCF. That's all we've got, right? We got x can come out. So x comes out, we have x squared plus 4. All right. Kim? How's it going, Kim? Is this anticlimactic? So my question to you, Kim, is how is this different than what we've seen up to this point? I mean, we've factored it, right? So what's different about that denominator compared to what we've seen? What type of factor is this? Linear, right? In the two previous problems, all of our factors have been linear, right? So this is linear, right? But this one is not. This is quadratic. Can we factor this further? No. Now, if it was x squared minus 4, could we? Yes. If that was x squared minus 4, then we would have 3 distinct linear factors, wouldn't we? We'd have x, x minus 2, x plus 2. We would just do a, b, c on top of those, and we'd be on our way, wouldn't we? But we don't. This is an irreducible quadratic. So here's how we do these. We say, first let's look at this. That's a linear, right? So I need a over x. Great, fine, done. Right? That's so far that's what it is. But now I have to deal with this irreducible quadratic. And Shay was saying this just a second ago. This is what you do when you have an irreducible quadratic. You put the irreducible quadratic here, but instead of putting a constant on top, you actually put a linear expression in x. Let me write it. bx plus c. bx plus c. That's the procedure from partial fractions. But let's try and understand why this is what we are going for. Do you notice that here, the degree of the bottom and top, they're off by 1, right? So this is a first degree, and this is a 0 degree. Here, this is a second degree polynomial, and what we've put on top is a first degree polynomial. So it's what we're hoping for later is that this will eventually maybe become a u sub, and the derivative of that will be up here, right? Off by a constant, perhaps. Or even better, what if we had c over that? Like, what if there was no term here? Formula 17. That's going to be arctan, because we'd have a constant over x squared plus 4. So that would be arctan. So it's like if we just have that, we should be able to do a basic u sub on this. If we just have that, we should be able to do an arctan. And if we have them both, then shit, we'll just split it up and do them each one on their own. Yes?
I knew my initial instinct was you just put a bx on there. When would you just put the bx only? Or is that
You wouldn't. You wouldn't.
Oh.
Anytime you have an irreducible quadratic, you always want to put a linear expression on top. Now, sometimes it's taught to do it this way. A over x plus bx over the irreducible quadratic plus c over the irreducible quadratic. Sometimes it's taught that way. I don't like that way. I just don't, because I'm just like, I'm always thinking, like if this is linear, I want to put a constant on top. If this is quadratic, I want to put a linear. Now we stop in this class, we don't go past quadratics on the bottom. But in theory, if you had a cubic on the bottom, something down here that was a cubic that you couldn't factor, then you would have the cubic, and then what do you think would be on top? A quadratic would be on top. And then you'd have to go after that, right? So it's more of like, does that make sense?
Yes, it does.
Yeah. Okay. Let me just remind you one more thing. If that's a minus, we're not doing this, okay? If this is a minus, we're doing x, x plus 2, x minus 2, b, and c, right? That's what we're doing. So don't mess up a sign, you know, be careful.
If we change the sign, like if we take a test and we change that sign just on accident.
On accident, right? Yeah.
We
Yeah.
get like error carry forward.
I might accidentally take off a lot of points. Just kidding. I don't know. I have to see what happens. I didn't mean to take off all 10 points. I apologize. Yeah. Okay. All right. So we have to go with this. Now, same game. We have to find A, B, and C. So LCD on both sides, right? Multiply through. And let's see who's up today. Let's see who's up. We've got G. Are you feeling better? I hear you coughing a little bit. Still trying to get over that? Or do you just decide to share it with us?
No.
Okay, so are you comfortable with the next line, G?
Yes.
Okay, so what do we got? We're going to clear out all the fractions.
So, a times x.
Okay, you're ahead of me. Hold on. So the left side is just the numerator, right?
Yes.
Okay, and then the right side is A times
X squared plus 4.
x squared plus 4. And then
bx plus c
bx plus c
times x.
times x. Okay, I need to put that in parentheses, don't I?
Yes.
Okay, make sure you understand this step, everyone. You're multiplying both sides of the equation by this, so it goes away on the left, and then we put it here, and we put it here, You know, the x plus 4's go away here. And then here the x's go away. But because you're going to multiply x times that whole thing, you have to have that bx plus c in parentheses. Good job, G. Now, shortcut?
It works for A, but.
You can get A?
Then
Yeah, you can't. See, I don't think, I mean, there might be a way we could wiggle around this, but I'll be honest. In the previous problem, I really didn't want to do the long way because it was a lot to have to expand, wasn't it? Like there was a lot of things we had to multiply out. Would y'all agree that like this multiplication is not that hard? I'm like, you distribute an A through, you distribute an X through, and you're done. So the long way isn't as intimidating right now, to me at least, than us sitting here trying to figure out how to kill off, you know, certain things. Another thing I should point out, you're never killing this off, right? You can't plug a real number in here and ever make that 0. So, and we're not allowed to play with imaginary numbers in here, remember? All right, so that's just multiplying out that right side. A passes through, the x passes through. Let's collect like terms. X squared's here. So I'm going to put these two together, and then I'm going to pull the x squared out of them. So I'm going to write a plus b x squared plus cx plus 4a. Yeah?
Why did you choose the direction again?
Why did I choose the direction?
Was that
A plus B x squared.
Oh, because I'm going to try and match the coefficients. So I always like to look at this as being a coefficient on the x squared. So the a plus b needs to match up with this coefficient. Just the number, right? Not the x squared, just the number. And then this c has to match up with just the number here, which is actually -1, right? And then this right here is going to be the positive 4. So I think we actually are going to know 2 of our variables right off the bat, aren't we?
Yep.
So let's write this system down. We know a plus b has to be 2. C has to be -1, and then 4a has to be 4. Do y'all see how I'm writing the system? Like all the a's, the b's, and the c's are kind of lined up, and then equals the numbers. All right. From here, is Juan here today? Juan? No Juan? There's 2, right? Well, let's just go with you, sir. So what's A from this? 1, and then C? -1. And then once you know what A is, right, Juan, you can come in here and get B? Right, so if we know this is no, wait, that's 1, right? So what's B? 1. Okay, so we know what A, B, and C are, right? We know them all. So now we're ready to go back and rewrite the integral. Okay, the original integral becomes, wasn't it a over x?
Yes, sir.
So it's 1 over x. And then plus bx plus c. So what would that be for us? B times x, so 1 times x, that's x. Plus c, that's really -1 over x squared plus 4 dx. We can do these separately. First one is just natural log absolute value of x. Second one, well, if you look back in your notes from yesterday, or sorry, Tuesday, that is a linear expression over a quadratic. that's irreducible. And so this is that method where I told you, like, I do it a certain way. You might go to tutoring lab. They might do it a little different. This is where I let u be the denominator, and I tried to force the numerator to look like the derivative of the denominator. So I'm going to do this on the side now. This is not just arctan, because you have an x up there, right? Okay, so I'm going to let u be x squared plus 4. Du then must be 2x dx. I don't have 2x dx, right? So what I'm going to do is I'm going to force that to be a 2x dx. So that was from last class, right? I'm multiply by 2 on the top and the bottom here. So this integral becomes integral 2x minus 2. There's 1/2 out front. And then x squared plus 4 dx. Is this looking familiar from last time?
Yes.
We really want it to be a 2x, right? dx? I've got the 2x, right? But then I have this minus 2. So what should I do now? Just split it. 2 integrals. Just split it. Because we can do 1/2 integral 2x over x squared plus 4 dx. And then when we split it right here, and we do the negative 2 times the 1/2, we're just going to get negative integral 1 over x squared plus 4 dx. Are y'all following me? That negative 2, that 1/2 come together to give you negative 1. That's where this comes from. This one is just a basic u sub, right? U is the bottom. Derivative of it is on top. This one is arctan, right? Formula 17. I think I'm ready for the answer. Natural log x plus, oh, Marissa, you're up. So antiderivative of this one, Marissa? 1/2 natural log x squared plus 4. Do we have to have the absolute value there, Marissa? Yeah, so you're always supposed to put it there, but with this particular problem, x squared plus 4 is never negative. So the absolute value is not necessary. But let's just, I mean, it doesn't hurt to have it. Okay, we'll put it there. And then keep going.
And then
Minus 1/2
arctan
arctan of x over 2 plus c. Good. So that 1/2 and that 2 here is coming from the fact that this formula 17, you have to account for this a squared, right? So the formula is 1 over a arctan of x over a, or u over a. And that's it. We're there. Yes?
You could have split the integral of x minus 1 over
You could have split it right here, right? But you would have had to have made a small adjustment because this x wouldn't have been the derivative of that. You would have been off by a constant. So you would have had to make adjustments. But you could have done that. Yes. All right. How many problems have we done today?
3.
3? Okay, so look at this problem. I like this problem.
It goes against my principle of writing it as small as possible.
We're going to do more of this next class. If you look at our schedule, we're supposed to do this section today, and then on Tuesday we're supposed to do this section also. So we won't spend all of next class on this, but we'll do a few more problems, all right? I didn't get it. I'm not going to have a chance to get into that book. A little disappointed. Well, maybe we will. We'll see. Who's up? Luke?
Yeah.
Where are you at, Luke? All right, Luke. So what are you thinking here, Luke?
Maybe long division.
Long division? What do y'all think? Degree of numerator and denominator the same? So you, Luke, you've already ruled out like anything else, like a basic use of. I think that's fair. Long division? I don't think that's a bad idea. Ugh.
You end up with like some constant plus.
I mean, I don't know. Could
Aren't they the same except for the? There's something about that.
I don't know.
Go straight in partial fraction decom.
How about
There's gonna be a lot of fractions in this one.
I mean, that's not the same problem, obviously, right? That's not what's there. It would be nice if that's what it was, right, though? Because then that would just be 1.
Yep.
But it's not. So, but that I could rewrite minus 3x as minus 4x plus x. That's still minus 3x. And I could rewrite that plus 2 as plus 3 what? Minus 1. Do y'all agree with that? I know that's weird, but that's the same expression, isn't it? And now what I can do is I can just split this right down here. All of that over that, and then all of this over that. And if I do that, then this becomes what? What's all of that over that?
1.
1 plus what's all of this over that? And guess what we just did without actually doing it? We just did long division. But they don't always work like this. Okay, so Luke, long division, okay, get it done. I don't expect you to all see this all the time, and if you don't, it's okay, you have long division. Long division would get us to there, all right? Now, we're not going to work this through. Charles? Charles, there you are. How's this going for you, Charles? Charles? It's going, yeah. So tell me what you see here. This is a what over a what? Quadratic, linear over quadratic, right? Now, didn't we talk about linear over quadratic last class? But there was something about last class that was very special about the quadratic that we were talking about. What was it? When we have linear over quadratic, this is that weird special method I showed you where we like multiply out in the front and make the top look like the bottom, remember? But there was a big if condition on that denominator.
If it had a coefficient of 1.
Something else. It had to be irreducible. That means we used that method from last class where I tried to like massage the top to turn into the derivative of the bottom if this denominator was quadratic and irreducible, meaning not factorable. Is this factorable?
No.
Is it?
No, no.
It's not?
I tried it. It's not.
So you have to be sure. That's the thing. We have to be absolutely sure that that's not factorable. So I don't know what your method is for that, but it's like an AC method. You can multiply those two together and get like 12. And then look at the coefficient out here, and that's like -4. And you're trying to come up with two numbers and multiply to be this and add up to be this. 6 and 2 work here, but they don't work here. You could do 6 and -2, but then that doesn't give you this. So this is not this is not factorable, which means you can use what we did last class at this point. So this is where you do like u is equal to 4x squared minus 4x plus 3. And then the derivative of that is what?
Is 8x.
8x minus 4 dx. And then you play this game where you try and make this numerator look like 8x minus 4. Yeah, you multiply. So I would split this up, right? Because you can do that antiderivative. And then do this, and so that becomes its own problem. Let's not do it, okay? I mean, let's stop here. But I would trust everyone can at least start going. We don't have time for it.
It's also the same equation that we did.
Oh, you know what? Yeah, I think I made this problem intentionally. That's right, I did make this problem intentionally. This problem we did last class. Yeah, because then, no, it's further up.
Problem 7.
Yeah, there we go. So that problem right there, see that? X minus 1 over that. Thank you for remembering that, Shay. That problem right there, if you go back and look in your notes, we've already done. But you go back and look, appreciate there's work to be done still here, okay? Quite a bit of work. Okay, you know what? here we go. Marissa, why don't you just, there's, starting here at number 23, all the way up to 64. Why don't you just pick one, and you just tell me, and I'll write it down. Let's see how much of this we can get done. At least get it set up. Whenever you're ready.
Okay, on the top, 6x squared. On the bottom, x to the 4th minus 5x squared plus 4.
Oh, not that one, though. No, I'm just kidding. Okay, so this is, I mean, I've never done this problem, so let's see how this goes. All right, so I'm gonna look at this real quick. U sub, no. I mean, this is 4th degree. The derivative, that's 3rd degree. I don't have that up there, so I'm not gonna go U sub. Pretty much looking like partial fractions. I don't need long division because 2's on top, 4 on the bottom, so I can go straight to trying to factor the denominator. And I can factor that. It's a weird type of quadratic. It's a quadratic type. It's not truly a quadratic, but it's quadratic type. That's what we call it in college algebra. So that would actually factor to be, Kim, what do you got?
Squared times 4 plus 1.
Would you like to ask whoever you're on the phone with if they can factor it for you? So what do we have? Minus 4, minus 1. Okay. Kim, I'm only calling on you. You know I'm calling on you because of your phone, right? I mean, we're all adults here, so I don't want to call out people for being on their phones. But I do find it somewhat disrespectful to be on your phone during class. So if you could please at least step outside or something if you got something important. Yeah? Okay. All right. No, yes, no, yeah, that's right.
You want to break
Okay.
this apart?
Yeah, now we got to factor a little more, right? We got to factor a little more because these are still reducible. They're difference of squares. So I'm actually thinking this problem's not going to be bad at all. Because once we get to here, what do we have? We have 4 distinct linear factors. And we're all the way factored. So now I can go to my college algebra, partial fraction decomposition, and partial fraction decomposition. I can go 6x squared over x plus 2 times x minus 2 times x plus 1 times x minus 1. And then here we go. This is going to be a over the first one, b over the second one, c over the third one, d over the last one. And what's going to be really nice about this is when I do the LCD on both sides, I'm going to be able to use the short method. And the reason why is because when we multiply through it, well, you just have to see it, I guess. Do you think you can handle it from here?
Yes.
Yes, I'm going to stop here. Imagine that you had numbers now, like you go through and you solve for these numbers. Isn't the antiderivative going to be easy? All of them are natural logs, aren't they?
Yeah.
Natural log, natural. Okay, let's go to another one. Whenever you're ready. Trying to find a hard one? Well, they're not necessarily harder or easier. So,
Okay, so
yeah, just look at something that looks weird to you.
on top, x cubed plus 6x squared plus 12x plus 6
What? Okay.
all over x squared plus 6x plus 10 times squared.
Oh, shit. Okay. Over that squared. Okay. Ooh.
Can I have different paper sellers?
Okay, so look, it's not as bad as it looks. Let's first talk about, we're going to do partial fractions, all right? I don't see us doing a basic U sub here. I don't see anything else. So we have to check, do we need long division?
No.
We don't, and you just have to be careful. That's cubed, this is squared, but this whole thing is squared, so the denominator is actually a 4th degree polynomial. So we don't need long division. Now I just need to see if I can factor that. So does this factor? Does that factor inside here? Factors of 10?
1 and 10.
1 and 10, 2 and 5. You're not going to get a 6 out of that, right? So that's an irreducible quadratic, isn't it?
Yeah.
Okay, Shay, what do we do with irreducible quadratics? So can I get the integral out of here just to save time and just be like, let's try to do our partial fractions? What do we put here? Shay told us, because he asked about it, like,
It's going to be the bx squared plus c, but it's going to be for power to the...
so when we have a quadratic here that we can't reduce, and we're going to come up here, we don't put a over it. What do we put on top? Bx plus c. But in this case, we're not using the a, so let's use it now. Ax plus b over the irreducible quadratic factor, right?
And then another ax plus
Ah, yes.
cx plus b
Plus another one over what?
the x squared plus 6x plus 10 squared.
And why are we doing that? We did the same exact thing when we had a repeated linear factor, right? We had to do like the linear factor, then the linear factor squared, then the linear factor, until we got to the highest power. Here, building it up. Here we have an irreducible quadratic, but it's repeated. So we first do the linear over the quadratic, and then we start building the power up. Then another linear, different linear, over the quadratic squared. And had this been cubed, we would do another one, what, ex plus, yeah, whatever, over that whole thing cubed. Yeah? All right, that is going to require the long method for sure. You are going to have to, you would have to now clear, like LCD on both sides, right? So it would be x cubed 6x plus 12x plus 6 equals, we're going to have the ax plus b times what? So when we, x squared plus 6x plus 10, and then this one plus, all you have is the cx plus d, right? Because you're multiplying both sides by the LCD. So it completely kills off here, but then only one of them kills off here, and then both of them are gone there. That's actually not too bad. That's not too bad. Expand, match your coefficients. 4 equations, 4 unknowns. 4 equations, 4 unknowns. I still have 3 minutes. Give me another one. I'm stopping, obviously. Oh, hey, hold on, time out. I shouldn't stop. I'm going too fast. Okay, let's say we figured out what A, B, C, and D are. Let's say we figured that out, right? Then how are you going to do that integral?
It's going to be 1 over u squared again.
Yeah, this is going to be a linear over irreducible quadratic. So this is where you got to kind of let u be the denominator, then make the numerator look like the denominator's derivative, and play that game, right? This, the exact same thing. U is going to be this, the derivative of it up there. You got to make it look like the derivative of this, but it's going to be squared. So on this one, we'll get like an antiderivative involving natural log. This one, the antiderivative will be something like u to the negative 1. Let's do a take-home quiz on that.
Let's take home quiz.
Yeah. What's wrong with that? Yeah. You like those?
Yeah.
Yeah. We won't do an in-class quiz next time. How about that? This will be a take-home quiz. So why don't we just, yeah, I'll put the problem back up. Oh, I'm going to put the problem back up here. It was, say again? X cubed
Plus 6x squared.
plus 6x squared
Plus 12x.
plus 12x plus 6 over,
X squared plus 6x plus 10.
All right, let's do that as a take-home quiz. I don't mind if y'all work together on it, okay? Just don't go sit down in tutoring lab and be like, I don't know how to do this, help me. Like, I would rather you try and figure it out with your classmates, all right? I'm not giving you that because I think that that's an exceptionally hard problem. It's just like, we're not going to finish it, so why don't you go finish it? And I'll give you some credit for it. All right, you all have a great weekend. Try to do as much of your homework from 6-3 as possible.